all know, right? A inverse equals to I. What will happen if I take norm of this both sides? This equals to 1 only, right? Generally, whatever you measure is 1 only. Sorry. Then what actually happens? Norm of A and norm of A inverse am I correct? This one? Which property it is? Sub-multiplicative property. Amit doesn't even know that part. That's what. Why to study? Why to read? No point to read all those things. Because in another 1 more week, you will be relieved from this course also. So just you have to slightly adjust. Okay. So A inverse equals to what? 1, right? Norm of this equals to 1. And this is what? This is called as condition number, which is K. So what actually happens, what you can see here, the Ka is greater than general 1 and K is minimum value equals to 1. But if K is actually more, what actually happens, we can have a difficulty to have the convergence. Okay? So always we can see that Ka minimum value equals to 1. That means the matrix is well conditioned. That means matrix, and this is actually, this will increase if you have all those kind of things. That means your lambda max versus lambda mean. So this is nothing but lambda max versus lambda mean. Lambda max by lambda mean. Okay. So lambda max and lambda mean, this ratio will determine. So if this max and mean are similar kind of probability, we can actually say that it's a well conditioned. So this K matrix is involved in well condition. And if the matrix is well in condition, what actually happens? This K will be very large. And then what actually happens when you do numerical calculation? Then error is right. This is the proportional error. Why this error actually comes? Because the A matrix has some error, numerical round of error. B vector has some round of error. And then solution will also have round of error. And round of error is delta A. We have two plus class. This is equals to A delta B bar or B delta plus delta A bar by. This is the thing you have two plus class. That means this is okay. It's all like proportional error. This is small one. Why is this small? If you look at the matrix, say 1, 1, 1, 1.005, and if you want to calculate, then what is the delta A then? Delta A matrix will be 0, 0, 0, 0.001. The delta A matrix. If you look at norm of delta A will be very small. So this quantity will be small, this quantity will be small, no problem. Determining factor is K, which is condition number. Okay? And then what actually happens, condition number is determined by norm of A and norm of A inverse to multiply. That will determine the condition number. Okay? And now the condition number is large, that means you have seen it, lambda max by lambda mean for this case is coming 10 to the power 4. So in that case what actually happens, if you do slight perturbation, if you have slight round of error during the calculation, instead of 1 you are actually putting 1.005, you can see solution will be very much different. And that will actually affect, so sometimes iterative process or sometimes the process. So this affects numerical convergence, this affects numerical convergence, iterative process, and so on. Sometimes solution will not converge because of this. Sometimes solution will not converge because of this. So this is the main agenda. So when you solve Ax equals to b, if there are some results like round of error, which gives delta A, which gives delta B, and solution error is delta x bar, the solution error, that is proportional error of the solution, will be depending on the condition number of the matrix, which is which is nothing but norm of A and multiplication of norm of A and norm of A cross. Okay, now that's clear, right? Okay. So next we will be going for. So we have already discussed the direct method. We have discussed so much things. We have discussed about we have discussed the iterative, non-iterative method. We have discussed the direct method, and direct method we have changed the rows. Okay, different rows. Okay, which is called as pivoting, partial pivoting, and changing rows nothing but changing the equations. And I never recommend to change the clock. It is dangerous because it will really hamper the entire system. So in this type of case, we have seen that how decomposition, Gauss elimination, all those things actually work. And those methods, direct method, will be less efficient if you have say 10,000 by 10,000 matrix or maybe 1 lakh algebraic equation. In that case, those methods will not be that much powerful. And in that case, we have to go for the iterative method. In contrast, iterative method is not that powerful. If your system is very small, it will take longer time. So when you use iterative method, you have to be very careful how much the system, and because what these days the people actually are using, who are actually developing the fast software. The software has to be very fast because the software cannot be slow. So for software purpose, when you develop finite differential quantitative algorithm, the 90% times, 90% of your CPU time goes for the solution part, solver part. So solver part has to be efficient. So when you have the solver part, it is actually your job to look at whether we will be going for the direct method, or iterative method, or sometimes you have to go for the banded algorithm, banded solver. Some of the issues I will discuss in the next semester. So of course iterative method has gained a lot of importance, and because of the large scale problem. So let's look at the iterative method. So iterative method thing is that we give initial guess. Say x0 vector. We are trying to solve Ax equals to. We are trying to solve Ax equals to b. You give like introduction method. Introduction method is also iterative method. It is not introduction, it is like introduction method. What introduction method you give? You give x old, you get x new. Again, the x new you assign as x old, you get x new. That is not what introduction method propagates. It is actually for the nonlinear algebraic equations. A set of linear algebraic equations, very huge system, and you are trying to solve it in initial guess. It will generate x1, will generate x2, and generate xn. Generate xn plus 1. What actually happens? There is not much difference here. Xn and xn plus 1. So in that case, what actually happens? You got the converse solution. And sometimes what may happen that this may not be solution, will not be changing. Somebody says you got solution. But to verify whether you got solution or not, we have to put it here. This Axn equals to b satisfied or not. If it is not satisfied, there is some problem. Okay? But generally that doesn't happen. But that is the way I always check. I just put xn here, and you have to have Axn equals to b. Right? Okay. So what actually happens? How to generate this stuff? In introduction method, we have seen that x new equals to x old minus fxo divided by prime xo, right? That is the generator. But here, how to generate this? How to generate these guesses? We have to generate. You cannot have arbitrary things, right? If you have arbitrary things, a problem. So, what actually the algorithm, the common algorithm is xk plus 1 equals to mxk plus c. So what actually happens is the x, so x0 m plus c equals to x1. Right? That's what it says. So this m is called as iteration matrix. This m is called as iteration matrix. This m is called as iteration matrix. So we have to develop an iteration matrix such that we can generate the subsequent vectors x0, x1, x2, then xn plus 1, xn plus 1 will not change much, and in that case we have the solution. And when you have the solution, so that means we get x2 equals to m will be what? mx1 plus c1, and we have xn plus 1 equals to mxn plus c. if x star is the actual solution. If x bar goes to x star is the actual solution, then what is the relationship here? Then what is the relationship here? X star equals to m x star plus c, because solution will not change. Solution will not change. Now it is possible to define ek bar, which is xk minus x star. That means, which is called as error at kth step. Express the exact solution. First step error is what? x1 minus x2. E1 bar. First step error. Second step error is x2 minus x star. Third step is p bar minus x star. Kth step is xk bar minus x star. It is dk bar. This is the way the error will come out. This is the way error will come out. The thing is that when you generate the error E1, E2, ek, ek1, ek plus 1, this error should, magnitude of the error, that means norm of the error has to be reduced, no? Length of the error. You have seen that, right? This is your x star, this is your x1, and this is your E1. Similarly, this is your x2, this is your x star, this is your E2. This E1 is more, E2 will be less. Then sometimes what actually happens? X and x star, they will be merging together. That means equal value is 0. So algorithm will such that this length of the error will be reduced to a diminishing value. Right? To reduce to a diminishing value. Okay? It will go on reducing. It will go on reducing. It will go on reducing. Right? It will reduce. So what actually happens? Xk plus 1 equals to mxk plus c. X star equals to mx star plus c. If you subtract, what you get? Xk plus 1 minus x star equals to m into xk minus x star. Am I correct? C will get cancelled. C is some constant vector. What you got finally? Ek plus 1 equals to m ek. So what we found from finally, error at k plus 1 step is nothing but m matrix into error at k step. So what is the condition? That error in k plus 1 should be less than error in k. What you can conclude? On what condition that will be satisfied? What will be the condition that will be satisfied? Huh? What is that? What m is less than means what? Can you say matrix A is less than what? Doesn't make sense to you.
Norm of n smaller than.
How will you prove it? See, norm of ak plus 1 and norm of p. These are length actually. Is that not length? This length has to be less than this length, right? That means if you want to evaluate length, we can write this way also. And just putting both sides there. Both sides put double bar. This is the mechanical way to teach. Okay. Then, what property should I put here? What property? Submultiple. That because you know only submultiple. There is no other property. Look at your notes now. What I am teaching, I don't know. Whom I am teaching, I don't know. Huh? Compatibility property. At least you could find something from the notes. So what will happen then if I apply the compatibility property? Compatibility property says that norm of Ax is less than equals to norm of A into norm of X. Right? So it will be less than equals to, am I correct? It is compatibility property, right? Okay. So these guys are length of this guy length of this, in between this fellow is that, which is what? Which is actually norm of the matrix M. Okay? Sometimes we call this as maximum norm. Maximum norm. Maximum value of matrix M or norm we call as rho M, which is also known as spectral radius. Which is known as spectral radius. We have not learned all those things earlier. I am surprised. I took a course in my BTech level in 4th year. BTech 4th year, elective was numerical techniques. And these things are covered. My time, imagine that. 92, I did my 3rd year, 4th year. 4th year, 2nd semester, I took that course. I still remember. Which was my favorite course actually. This was all taught. 22 years back when I did BTech, it was taught there. So imagine that these things are there with me for the last 22 years. Then I went to IISc Bangalore, the instructor taught. Then I was sleeping all the time in the class because these things were not taught, everything was very easy. One day he caught me while I was sleeping in the class. And I used to carry my BTech classroom all the time. That classroom is still with me because that was my favorite subject. I went to his office. I showed these are the things already covered. He removed his specs and was trying to verify whether he's seeing correctly. I said, all those things are covered. Do you think I can sleep or I will be awake? He didn't say anything, he just kept quiet. That is the thing. So that is the way the coverage was there in the BTech in my class. And after that, so many instructors taught numerical analysis. People used to come from Canada, US and all. They used to visit IISc and I used to attend their classes. So I can tell you, numerical analysis course I have taken from 10 different professors. Okay? And so that's what, whatever I am teaching, you may not be able to find any of the books. Then I compared all the lectures and I found my own way how to teach it. So generally I used to offer numerical techniques class, but these days I am offering so many courses, that's why I am not offering that course anymore. But if some people are interested, then I can see whether I can offer that course. But you can see that is a beautiful way to represent that. So length of the K plus 1 iteration is nothing but the spectral radius of matrix M into the error of magnitude of the error of at the kth step, right? And of course it says that if rho M less than equals to 1, that's it. If rho M is less than equals to 1, what actually happened? The Ek plus 1 will be less than Ek. Okay? So rho M has to be less than 1. So whatever we do, Gauss Jacobi, Gauss Seidel, whatever method we derive, we have to see the iteration matrix is such that the spectral radius of the iteration matrix must be less than 1. And how to calculate? Best thing is to calculate the lambda, maximum value of lambda. If you say, okay, maximum value of lambda is less than equals to 1, you are all set. Right? Best thing is to calculate the maximum value of lambda, because that is what we have seen. Lambda is a good measurement. We have seen the condition number also. Lambda is a good measurement. Right? With that, we can actually conclude that, okay, we have iteration matrix, we calculate the maximum value of lambda, and lambda is becoming less than or equals to 1 for this condition, and based on that, one can conclude, okay, this method will converge for this condition. This kind of conceptual problem is going to come in the exam. First question will be. Okay, so be careful what I am actually teaching here. Okay, so let's talk about first we will talk about Gauss Jacobi. Now this Gauss actually, you have heard about Gauss, right? Gauss I think you all have heard, and why Gauss is so famous, and Gauss has a lot of students like Jacobi, Seidel, and Gauss did a lot of work, and all of his PhD students like Jacobi, Seidel, Jordan, these people actually they are all, they also pioneered about the world. So Gauss, when Gauss was I think 4 years old, he went to school and he was very naughty. And Gauss was doing was disturbing others. He was not listening to that what the class teacher was teaching. The class teacher asked Gauss, you add 1 to 10,000. So class teacher thought that the Gauss will be busy for 2-3 hours and the class will be peaceful. Then again Gauss started disturbing the people within 2 minutes. Then teacher said, have you finished the problem? Gauss said, yes, I have finished the problem. How did he solve it? Do you know that? Huh? How did he solve this 1 to 10,000 in 2 minutes? Huh? Not any plan, but he didn't know the formula. At the age of 4, how can he know the formula? Poor Gauss, just like this only. The Gauss, how he won't even know what is n and all. He barely used to know how to do summation. Any 10 plus 1, even what level, n plus 2 level, we have actually found the formula. How Gauss, at the age of 4, will know all this n 10 plus 1 formula? And he is not a child prodigy and all those. He is a very normal person. But he has a very good presence of mind. Can you guess? So what actually I am asking, what he did at the age of 4, can you guess now what he did? You are not at the age of 4. Your age may be 4 times or something, 5 times. How did he solve in 2 minutes? Any idea? How many? Whatever Gauss did at the age of 4, there must be at the age of 21, right? Yeah. 21 and whatever. I am asking you the same question. Or Gauss sir did it, so you can also do, no? Any guess? Huh?
90,000, adding up 1,000.
10,000. Yeah, 1,000 was no problem.
Right, 1,2,000 just.
Yeah.
And reverse.
That's the way Gauss did. Gauss was like you only. Okay, so what Gauss did like this? It became what? So if you look at each is 1,001, right? Each summation. How many terms will be there? 1,000 terms will be there. Answer is 1,000 1,001. Only thing he had to take 2 minutes to multiply. That's why he took 2 minutes. So that is the way Gauss was genius actually on the numerical and number theory, the algebra, whatever ways. Of course, we also had genius mathematician Ramanujan, but people say that Gauss is what Gauss and see, our unfortunate part is Ramanujan died at the age of 32. Okay, we don't know what would have happened if Ramanujan would have been survived for another 50 or 40 years. Would have been really remarkable for the mathematical science, but we are unfortunate. Because some of the genius mathematicians, they died very early. One is Abel, one of the mathematicians. Have you heard of Abel? Abel is good. Abel is the mathematician who is in mathematical analysis, topology and all those things, and he also died at a very early age. So these are the laws of severe laws of mathematics. But we are really fortunate that Gauss survived for a long time and really did pathbreaking work, mostly for the numerical, event physics, so many places Gauss played remarkable roles. So we are really grateful to Gauss, and because of Gauss, so much of numerical techniques, so much of numerical things have been discovered, and we are in a good situation. So we'll start with Gauss-Jacobi. Do you remember Gauss-Jacobi? How to do Gauss-Jacobi? BTech level. We will start from BTech level, then we will derive the integration methods. We will do the BTech level, then we will do the integration methods. Gauss-Jacobi, do you remember? No. Okay, I'll write down the equation. I want to solve by Gauss-Jacobi. I want to solve it. My initial guess is x1, x0, which is x10 x20, x30. Initial case. How to get x1? That's what I'm asking. We have done it in BTech level, right? It is covered. Was it covered? It is covered. Gauss Jacobi method. Amit, you remember? You don't remember. Anybody remembers? People said covered. Yeah. Where it is covered? Your US masters?
No, BTech.
BTech level. You still remember BTech? I am very happy to see that. Okay. Okay, sir. Then can you tell?
In the first equation, it takes all the other variables.
Other variable is all variables.
Okay, v1 minus a12 x2 plus minus a13 x3 divided by a11.
Correct.
In the second equation, you keep x2 here, so v2.
That means the diagonal terms will be actually taken in the left hand side and off diagonal terms taken right hand side.
Yeah.
So okay. So what we will get x11, which is nothing but b1 minus a12 x20 minus a13 x30 divided by a1. So I am generating a new guess. I am generating a new guess x11. This is the old guess. It is already there. Generate a new guess, right? x21, which is b1 minus, b2 minus a21 x10 minus a23 x30 by a22. x31 will be what? x31 will be, who can tell me? Not you. Amit sir. b3 minus
A31
minus a31
x10
yeah
minus A32 x20.
a32 x20 divided by so you got x11 x31 and x31. Okay, we got x11 x21 and x31. Similarly, you can generate x2 the same way. Okay, so x21 will be b1 minus a12 x21 a13 x31 divided by a1. So you can pick up some problem from your textbook and try to solve numerically. Try to solve numerically. Try to solve numerically the first step. The question is, why it works? These things were not taught. Was it taught to you last bench, sir? Why it works? What is the equation matrix? The equation matrix is less than 1 for this case. Why it will work? You don't know. Okay, so that's what we are going to cover here. The economic course comes, we are doing it because most of the time numerical analysis people do manually. This is the technique. Why we are doing, nobody knows. How we are doing it? That I don't do because that's why I never teach numerical analysis techniques. I teach numerical analysis. If you do analysis, you will actually appreciate better why a method will work. And if we know why a method will work and how it works, then we know so many methods. Then for a particular problem, which method is suitable, if you know analysis, you can do better. That is becoming numerical one stop. So if you use doing that, go and shout. Some shouting is required. See, without shouting, people don't work in our country. So this type of thing, how can you write mathematically? You can write say xi k plus 1. Generalized way. I want to write generalized way. How to write generalized way? N by n matrix, n vectors, ith variable, k plus 1 is interesting. How can you express? What is that? 1 by aii. Okay, 1 by aii. Bracket bi minus Summation, okay, very good. What is that? I will say J. If you put K, gone. K is already there. 1 to A now. J equals to 1 to I minus 1. Okay. A I J X J K minus J equals to I plus 1 to N A I J X J K. Am I correct? Yes or no? See, you can see that diagonal terms are not considered right hand side. That's why I'm writing 1 to I minus 1, I plus 1 to I is not there. That's why for this kind of problem, you have to be very careful. If there is a diagonal term 0, we have to rearrange. If you don't rearrange, we will get nan in the problem. Understand, right? In this kind of operation, if A11, A22, A33 there, and some values are 0 diagonally, then you have to rearrange. That kind of adjustment or pivoting, okay, has to be there. Otherwise, what will actually happen? If these guys will 0, gone. The first program itself, the first step itself, you will get nan, your job is done. That's it. You will say some method doesn't work. Method works. This arrangement of the equations are very important.
The diagonal element should be dominant.
That will be coming later. That will be coming later. But thing is that make sure this guys are not 0. If guys are 0, they will be appearing here wrong. Then big problem. Then we will say that Basak sir is teaching something which is not working. Okay. So that's what I'm telling. Last time it happened. Last time they told us it's not working what you were saying. I said, hey, what to do? Doesn't work. But some people sometimes it doesn't work, some people it works. So it won't be working for you. Okay, because you won't be arranging. You will say it doesn't work. So you are right. It is not working. For my job is I will make sure it will work. So you both are correct. It doesn't work for you. It works for me. The point is the exam, you will show it doesn't work. Unfortunately given 0. Okay, you are correct, but you will get 0. It's a very unfortunate situation. You will do the thing, you want to do the adjustment, and you will say, fine, it doesn't work. You are correct based on the common situation, and you will get 0. But thing is that it works. Okay, so you have to be very, very careful. What will be the next step? More compact way. More compact way. So you can write AII xi k plus 1 equals to bi minus summation j equals to 1 to I minus 1 aij xjk minus summation j equals to I plus 1 n aij xjk. This in terms of vector notation, vector and matrix notation. Vector and matrix notation. How to write? AIIXI. I want to write in terms of bar and double bar. That's called vector and matrix notation. That means what? I will show you one term first. Then we will show me other terms. First term is A11 x1, A plus 1. Second term is A22 x2 A plus 1. Like that you go. Okay. That this kind of thing, how can you write in the matrix form? We can write this as matrix and vector multiplication. Okay. Why this matrix? Because 2 index is matrix, 1 index is vector. So it is quite clear that this is an outcome of matrix and vector multiplication. Correct, huh? What is that matrix and what is the vector? Diagonal matrix. A11, A22, A11. All 0, these guys. x1 k plus 1, x2 k plus 1, and x7 k plus 1. So we will write this one as v x bar k plus 1. Am I correct? Yes or no? dx bar k plus 1. B I will reduce it to d bar directly. Right? Next is this ij. Where it is going? It is coming this term, this term. So I will be taking this, this and this. What is this matrix called? So my matrix A11, A12, A1, A21, A22, A23, A31, A32, A33. This is my diagonal. This fellow is remaining. This fellow is remaining. Very nice structure. If you combine these three, you will get a complete matrix. Fantastic. So this portion is what kind of matrix? Lower, not lower temporal matrix, lower diagonal matrix. And this is called as upper diagonal matrix. So these terms should be coming here, right? So this is lower diagonal matrix and this is upper diagonal matrix. Am I clear? Okay. Remember that what we have to find? We know that, right? The name is the iteration matrix. Now we are slowly approaching to find out the iteration matrix. What is that iteration matrix then? dxk plus 1 equals to minus L plus u xk plus b. Then xk plus 1 equals to what is that? Xk plus 1 equals to, now you tell me the answer. Minus 1 by d. How would it be possible? Can you take 1 by matrix? Minus d inverse. Minus d inverse L plus u xk plus d inverse b. So iteration matrix has been defined, which is M matrix is minus d inverse L plus. And what actually happens? The row M has to be less than 1. If it is not, this method will not converge. So this is the way. So if any matrix is given, A matrix, it is possible for you to construct L, possible to construct for you AU, possible to construct D matrix. Take D inverse, addition will be there, and you find out the eigenvalue. If the lambda max is less than equals to 1, you say Gauss-Jacobi method will work for it, for any initial case. Okay? Gauss-Jacobi method will work for this, for any initial case. Otherwise, it will not. Right? So that, but this part was missing in your class. What they taught? They taught this technique. You also went in the exam, did like this, job is over. We are not, we are not doing something like clerical work. The mathematics can be taught in a clerical manner. These are good. I am not saying that clerical work is bad. Clerical work is good because we don't exercise much brain, but we do systematic procedure. But with this way, you cannot do any research. You can solve some problem, get some marks, go home and sleep. But research-wise, you need to think about why this method will work, and this iteration matrix play a critical role. D inverse B is nothing but, so C equals to, again D inverse B. So this iteration matrix plays a powerful role whether the method will work or not. Whether the method will work or not, iteration matrix will play the powerful role. Next we will be going for Gauss-Seidel method or Gauss-Seidel method. What is the spelling of Seidel? A-C-I-D-E-L. Gauss-Seidel. Okay, I will not delete this part. Our friend will tell me how to work with Gauss-Seidel method.
It was Jordan method to wait for the entire
And you are telling so big things I am not able to understand.
Update it immediately.
I don't understand what immediate update.
Once you find x1 from the first equation.
I don't talk like this. That's why I don't understand your way, because your way is much advanced level. You came from US, no. I never went for US for studies. Problem. I studied everything in India, and Indian way is very simple, because Indians cannot think very complicated way. Because we are all small people. Yeah. X11, first to find out. That will remain the same. X21 will be. You are talking correctly. Because you are talking, my so far you are not being in US. That's why at least you are talking in our language. B2 minus. Wow, excellent. That's what I want the answer. Okay, divide by B2. X31. That means whatever you are finding out here, whatever you, so at this point nothing was known. You found out x11, you put it here. x30 is not known. And at this point you can see x11, x31 all are known. So you are actually going slightly one step ahead. Okay, whatever you are evaluating, you are actually putting it. Okay, now you can also find integration matrix for that. We can find integration matrix for that, and we can see that on what condition Gauss-Seidel method will work, and also you have to prove that why Gauss-Jacobi method will not work in efficient way compared to Gauss-Seidel method. In another word, why Gauss-Seidel method is more efficient than Gauss-Jacobi method. Why Gauss-Seidel method is more efficient than Gauss-Jacobi. So here x will be x1 same, but only the way its procedure is different. So now we will start from here. We will start from here. xi k plus 1 by aii bi minus, what will be the situation? Gauss-Seidel method. You see the diagonal terms are taken care of. That's okay. Only using diagonal terms evaluate. Only thing is when you talk about this lower and upper diagonal, you can see that for lower diagonal case, everything is known. Upper diagonal things are unknown. Right? For example, think about that one, what I am saying. So for this first case, these are unknown. We put x0. When you come here, this is not diagonal, it's already known. For this case, both are known. Are not here. Now what will be my technique here? It is not correct. This is for Gauss-Jacobi. For Gauss-Seidel, what will be the generalized way to represent? For the Gauss-Seidel, what is the generalized way to represent?
xj k plus aij xj k plus k plus.
This one is okay. Excellent. That means you are very good in numerical. Amit is again proved to be very good in numerical. Okay. Next step. You tell me the equation matrix now. What will be my equation matrix? I will not show the steps. You will show the steps because now we have proved that you are very good in numerical. Now you give me the answer. You are very good in numerical and you give me the answer. M matrix is
Minus D inverse
minus D inverse.
L into x k plus 1.
All wrong only. You are not good in numerical now. Maybe afterwards will be good.
Minus D plus L whole inverse.
Into U. Is it correct what you are saying? Nikita, can you repeat once again what you said? Is it correct? You are saying it's not correct. Amit is saying not correct. Any other person? Amit is very much up against of your answer. I don't know if you are friends or enemies, I don't know. He is not happy with your answer. I didn't say whether I am happy or not. Second bench, madams. Is it correct answer? I didn't say whether I am happy or not, but he is very much upset. He is upset with your answer. Are you agreeing, Vasudha? Okay, that means you are not happy with the answer. Many people are not happy with Nikita now. Now you are trying to change the answer, like a politician. Politicians sometimes do correct things, but if the public is not happy, they will do the incorrect things. I can give the examples not here, sometimes private. Don't act like politician, act like a scientist. People may not be happy with you. You know what Galileo did? Galileo's example you know, right? Only Galileo was murdered. But he did the correct thing. He told whatever is correct. Okay, Amit, what is your answer?
M is equal to minus B inverse into L into x raised to k plus 1.
Okay, so what Nikita said correct only. This is the final answer. So will anybody agree with her? That's so many people. See, we have some friends also. Yeah. So luckily I am glad that you have these friends because you should be one-sided. So what Nikita did correct only. Can you explain to us? Next step is what? D x k plus 1 equals to b bar. Don't say b, b bar minus L es minus u. Excellent, very good. Next step, tell me you are doing very correctly. Next, d is yeah, it should be transferred because if you get x k plus equals to x plus c, so it is d plus L x k plus 1 equals to minus u x k plus b. Then rest of the step is very straightforward. Minus e plus L inverse u x k plus b plus L inverse u. What was the mistake, Amit? For you? What was the mistake you had? You were very much strongly, you were very fun to accept her answer.
I generalized it from the first one.
You didn't generalize anything. You did something. Right? This is generalized well. Okay. Now, this A matrix is for Gauss Jacobi. Right? Gaussian M matrix is minus D plus A inverse U matrix. Right? Gauss Jacobi is this one. Gauss Seidel is this one. Is it possible to prove rho m Gauss Seidel is less than equals of Gauss Jacobi? I am giving you some open question.